hello students. I guess there are only two of you today, but we are going to have a oh, okay, you're a little bit late. That's all right. Hi Max, welcome. Recess ended already. Wow, that was excellent. All right, thanks for coming. So there's a Warriors game tonight. You guys should all go.
Kevin Durant.
Kevin Durant. That was unfortunate. Okay.
He's out. He's injured.
That was unfortunate, but we only got a few minutes here. Okay. So what we're gonna do is we're gonna learn about the different types of triangles today, right? We're going to learn about the different types of triangles, and you see triangles all over the place. You see triangle as an instrument, the triangle, but also we see triangles a lot when we try to map things. If you guys have ever looked at a map, you'll see a lot of triangles. Hey Max, we got recess next period. If you could just keep it down a little bit. So these are the types. So what we're going to do is we're going to review three types of triangles and also three angles that can be applied to those triangles. So have you guys ever heard of a scalene triangle?
No.
So a scalene triangle has no congruent sides. What does congruent mean? That just means they have the same length. So there are no sides of the same length. Does that make sense, Max?
After the explanation, I'm starting to get a little more. I need a little time to look at it, but it's starting to make sense.
Does that make sense to you guys?
Yeah.
Excellent. So for example, is this an example of a scalene triangle?
Yes.
Yes, because all these side measures are different.
6, yeah.
Is this an example of a scalene triangle?
No.
No, because even if this was like 7, you still have 2 of the same side. Does that make sense?
Mm-hmm.
Okay, excellent. Next type of triangle is an isosceles triangle. That means that you have exactly 2 congruent sides. So 2 of the sides have to be equal, and then the third side can be whatever it wants to be. Yeah, Caitlin?
So is that one an isosceles triangle?
This one is indeed an isosceles triangle. So this is an isosceles triangle. I didn't write the side measure here. I don't really need to. It looks longer than 4. So we're going to say that that's an isosceles triangle because there are exactly 2 congruent sides out of 3.
But I thought you couldn't judge a picture by like what it looked like. I thought you have to have the measurements.
Yes, that is a good point. That's a good life lesson. But we will simplify a little bit here and I'll let that slide just because we only have 2 minutes left or so. So for example, that's an isosceles triangle. Equilateral means that all 3 sides are congruent. So all 3 of the sides have the same measure. And so we have, and what that means is that all of the angles have the same measure too. That's one of the consequences of being an equilateral triangle. And then we also have 3 different types of angles. Have you guys heard of acute, or right, or obtuse? Have you heard of any of those?
Right angles are 90 degrees.
Right angles are 90 degrees. You are right about that. So equal to 90 degrees, they form a perpendicular. So if you're going straight on a highway and then you turn right, that's a 90-degree angle. Acute means that you're less than 90 degrees. And obtuse means that you're greater than 90 degrees, but not too big, right? Like you're not past 180, but maybe 100 or 170. Those angles work. So is this what kind of triangle is this?
Isosceles.
Isosceles. And you guys realize that all of the angles are less than 90 degrees. Okay, these are a little bit less than 90 degrees. How much time do I have?
You have 2 minutes left.
Okay, so
You're
we're
at 3 minutes.
I'm at 3 minutes. Okay, so 1 minute, 1 more minute for the teaching, and then we're already at recess. That's excellent, huh? So this is an example of a right triangle, but it's also a what type of triangle? Not just a right triangle, but also a scalene. That's excellent. This is an example of an equilateral triangle, but we could also call it an equilateral, but also acute, because all of the angles are less than 90 degrees. It turns out that in an equilateral triangle, if all of the 3 sides are the same length, all of the 3 angles are the same. Now we know that for a triangle, the angles have to add to 180 degrees. So if we have 3 angles and they add to 180 degrees, what will be the measure of each angle? 180 divided by 3?
60.
60. Wow, that was good math. That was really, you did that really in your head really fast. That is excellent, Max. Coming into class late, you have redeemed yourself, my friend.
I appreciate that.
That is excellent.
I'm good with numbers, not always letters, but numbers.
What we're going to do now is we're going to do a chant. So this is a little chant, this is a little song that should help you guys remember what we've talked about today. I know this is a really fast lesson. We're going to have an hour-long recess time. So, Scalene ain't got no scale. Isosceles need ice cream. Why? Because it kind of looks like a cone, right? Like if I took an ice cream in the summer and I just plopped it over, there's some ice cream here, right? Next is equilaterals. So equal. That's the best I can do for that one. Right for summer? Let's say 90 degrees. Does that make sense to you guys? Probably about 90 degrees as a right angle. And acutes, they're so little and cute, right? They're less than 90 degrees. So they're very narrow angles, and the big obtuse, so wide and loose. So they're kind of the fat angles that stretch all the way out. So this is an example of an obtuse angle. Do you guys see another obtuse angle?
The 121.
The 120, yes, indeed. So can you guys sing this real quickly so that we don't cut into recess? Scalene ain't got no scale. Isosceles
need ice cream.
Equilaterals so equal. Right for summer, 90 degrees.
Acute,
So little and
cute.
The
big obtuse, so wide and loose.
Thank you so much, guys. No homework tonight. You did excellent. Have fun at recess, and I'll see you tomorrow.
Thank you, sir.